Welcome to today's lesson. We are going to look at experiments to demonstrate cohesion, adhesion, and surface tension. We start with the definition of surface tension, where we say that this is the force that causes the surface of a liquid to behave like a stretched elastic skin. I'm sure you have ever tried to push your skin using the blunt side of your ball pen. Whenever you push, you find that point there is a depression. So when we talk of the surface tension, the surface of the liquid behaves like that skin. There is a depression where you are putting that ball pen. Therefore, whenever we have any object that will float on this surface, there will be a depression. This force is due to what we call the cohesion. And cohesion, as we are going to see later, is the force of attraction between molecules of the same kind. We can have a look at molecular explanation of surface tension. I want us to consider a water in a beaker. Water is made up of molecules. So a molecule that is deep inside the beaker is surrounded by other molecules. It's like now when you are seated in a row and you are at the middle, you find that you are surrounded by other students. So the force of attraction between you and other student is cancelled. The same case, you have a molecule that is at the middle of the beaker. It is deep in the liquid. It is surrounded by other molecules. So the force of attraction between that molecule and other molecules is zero. It has cancelled. But now take a case where you have a molecule on the surface of the liquid. You find that on the vapor side, there are less or fewer molecules, and therefore the force of attraction between now the other sides and the vapor side will not be equal. And because they are not equal, we will have what we call the resultant inward force. And that resultant inward force is what is causing the surface to be in tension. Then we look at situations where we can have surface tension. One, you have a steel razor blade or a needle floating on the surface of water. And this happens when you put it carefully. Then you have a glass of water can be filled above the brim without water pouring. You can look at the diagrams. In the first case, we have a needle that is floating. This needle is made of steel, which is denser than water, but it is floating. But remember, you have to place it carefully. As you place it carefully, you ensure that you don't break the surface, and therefore, the surface of this liquid will behave like a skin. You will have a depression where you have the pin or the needle floating. Then in the second diagram, you have the tumbler or the glass. You are able to feel this when you put water carefully. All this is because of the surface tension. Then we have another case when you have bristles. When you put these bristles of a brush inside water, they spread. When you remove them, they cling together. This clinging is due to the surface tension. You have a drop of water that is coming from a water tap or a burette. This drop first grows, it increases in size, then it stretches before it falls. This shows that there is surface tension on that drop. Then we have that the surface tension will always act to ensure that it reduces the area. And we can have these two examples here. We have a funnel. You have put this funnel on a soap solution, and therefore you have the soap film. Then you blow. As you blow from this side, the soap solution or the soap film will increase in size. But when you remove or when you withdraw your blowing, you find that it recedes. And finally it will go up to where we have the neck. Why? Because in the first case, there was a larger area. And we have said that the surface tension will always act to reduce the surface area. So it has to reduce the surface area, and it will do that by receding, as you have seen this bulb, and it will go to where we have the minimum area. Another example is when you have this loop. When you have this loop and then you dip it in a soap solution so that you can get the soap film, and then you break the party board X, you find that this thread will form a perfect curve. This is because the surface tension is only acting on one side, and this will act so that it can minimize or it can reduce the area, so that way it is able to pull it and form a perfect curve. Then we move to factors affecting surface tension. We have impurities, and here we say that this one reduces the surface tension. When your needle is floating, I want you to go and try this. When your needle is floating, just make few drops or put few drops of soap solution and see what will happen. You will find that your needle was floating or your razor blade, but on putting the soap solution, that needle will sink immediately, because the soap solution weakens the cohesive force, and this cohesive force is the ones that are responsible for the surface tension. So as you weaken the cohesive forces, then you reduce the surface tension. Then the second factor is temperature, and here we say that rise in temperature reduces the surface tension. So when you increase the surface tension, or when you increase the temperature, what you are giving is the kinetic energy, the energy in motion. So those molecules will acquire a lot of kinetic energy, and therefore they will move vigorously. These molecules are not stagnant, they keep on moving. So when you give them a little energy, they will start moving vigorously, and as they move, they will increase the distance between them, what we call the intermolecular distances. When this one is reduced, then you reduce the force of attraction, what we are calling the cohesion force. When the force of cohesion is reduced, then we say that surface tension is lowered. So rise in temperature reduces surface tension. Then we move to consequences of surface tension. We have that water insects can skate very fast without breaking the surface of the liquid. And also we can have mosquito larvae floating on the surface, and this can increase the breeding of mosquitoes, which in turn can bring about the malaria. So to avoid this, you are supposed to oil any stagnant or still water. By oiling is like you are adding impurities to your water, and we have seen that by adding impurities, you lower the surface tension, and this will make the larvae sink. Therefore, oiling will control the breeding of mosquitoes. Then we move to adhesion, or what we call adhesive force, and this refers to force of attraction between molecules of different kind. In this case, we can talk of a molecule of water and glass, or a molecule of mercury and glass. Molecules of different kind. This is what we call adhesive force. Then we have examples where we have adhesive force. We have liquid wetting the glass. Have you ever tried to put water in glass, and then when you remove or when you pour the water, you still find some particles sticking on that glass? The reason as to why it sticks is because of adhesive force. Those water molecules are being attracted by the glass molecules, and therefore they stick. Then we have paint sticking on the wall. When you are painting, the paint is you are able to paint the wall because there is attraction between the paint molecules and the wall molecules. When you are writing, you are using ink, or when you are making a mark on a chalkboard using a chalk. All these are examples where we have different kinds of molecules, and therefore we have attraction, and that attraction is what we are calling adhesive force. Then we've moved to cohesive force, or cohesion. This refers to attraction between molecules of the same kind. In this case, we can have a water and a water molecule, or a mercury and a mercury molecule. The molecules are of the same kind, they are similar. We can have the cases where we have adhesive and cohesive force acting. We consider a capillary tube dipped in water. We have two capillary tubes. The first one is wider and the second one is narrow. As you can see, when you dip them, the water level on the capillary tubes is above the water level on our basin. Why? Because in here, as we can see, the force of attraction between water molecule and the glass molecule is high, and that is why the water molecule are just rising to ensure that there is more contact with the glass. So we have the reason here. The rise of water up the tube is due to adhesive, the force of attraction between glass and water molecules being stronger than the cohesive. So more water molecules are moving up so that they can be in contact with the glass, because adhesive force is greater than cohesive. Then we have that concave meniscus. This is because again of adhesive force being greater than cohesive force. Then we can have a second case where now we replace the liquid. We have the two capillary tubes, but in this case we use mercury. When you use mercury, note where we have the levels in the capillary. The mercury level is below the level on the basin. Why? Because the cohesive force is stronger than the adhesive force. In other words, we are saying the force of attraction between mercury molecules is greater than the force of attraction between mercury and glass molecules, and therefore mercury molecules tend to stay together because they are strongly attracted to one another. And then we have that convex meniscus because of strong cohesive force than adhesive force. Then we go to our third case where we have water on a clean and waxed glass surface. In the first case, we have a clean glass surface. When you put a drop of water, it spreads. And of course, when you remove, you find that it wets the glass. In the first case, we have strong, or we can say that the force of attraction between the glass molecules and the water molecules is stronger than the force of attraction between the water molecules. But when you wax them, now you reduce the force of attraction between the water molecule and the glass molecule. So in this case, we have this explanation. In the first case, the water spreads because adhesive force between glass and water molecule is stronger, and that is why it is wetting. But in the second case, we are saying by waxing, you reduce the adhesive force, and therefore, when you wax, then you have that the cohesive force becomes greater than adhesive force, and therefore, water molecules are able to form spherical balls. Then we move to assignment or quiz yourself. If you look at these questions, you're supposed to explain. They are coming from what we have just learned. Make sure that you revise. As we said at the starting, we said that avoid cramming, but ensure that you understand the concept. Evaluate yourself and make sure that the answers are coming from your head. Thank you and welcome to our next lesson.